Hi everybody, this week we begin talking about electricity. To start with, let's talk about the basics of electrical systems. How do electrical systems work? Well, first of all, you need a circuit. A circuit is a path for the electricity. When electricity flows from one point to another along a path such as a wire. Amps or current are the actual process of the electricity flowing along that circuit, and it's measured with the letter A. Volt or voltage is the force, and 1 volt is a unit of force. It drives the current along the circuit. And a watt is basically 1 amp flowing under the force of 1 volt, and it's used to measure how much electricity is being used. Now, all metals conduct electricity, but the best ones are silver, gold, and platinum. Copper and aluminum are the least expensive. Insulators are materials that virtually stop the flow of electricity. Glass, mica, and rubber are good insulators. Now there are two types of current. There's alternating current and direct current. Alternating current is when the electrical current will change direction in a regular manner, so it will go kind of back and forth. Direct current has a constant flow rate from one source, such as a battery, where one pole is always positive and one is always negative. When electricity reaches a building, the voltage must be reduced by a transformer. Each building or small group of buildings will have a transformer for this purpose. The voltage is reduced to about 230 to 240 volts for small buildings and then reduced again to 120 volts for household use. Photovoltaic cells are basically panels that convert sunlight directly into electricity, solar electricity. Now, they do not use the sun's heat for the electricity, but use the sunlight. He can actually affect the efficiency of a solar panel. They were developed initially in the 1950s by the space program, and small versions of these can be found on calculators and watches. They're used for traffic signals. And buildings with good access to the sun and flat roofs, or a roof that faces the east or west, are really good candidates for photovoltaic systems. Now, when designing the electrical system, first the engineer will estimate the entire building's electrical load. As a designer, you need to provide the electrical ratings of all the equipment that you specify to the electrical engineer. And there are various people that may design the lighting for a building. The architect, a lighting designer, you may have some impact on that, and also the electrical engineer. Interior designers are responsible for showing the electrical system information on their drawings as well. The electrical designer will use this plan to help design the system. And here are some various items that are typically shown on your plan. So you'll show the lighting, switching, the receptacles, all the data and telephone and cable outlets, smoke detectors, any fire safety equipment including fire alarms and fire exit signs, things like that, system panels, so where the electricity can be accessed, and also specific appliances that need higher voltage, like range ovens or dryers. Now, there are likely two electrical systems in every building. There's the electrical power system, which distributes the electrical energy through the building, and the electrical communication system, which sends information via the telephone data and cable lines. Now, the electrical communication system is sort of becoming obsolete because we've gone pretty wireless. For the most part, there aren't a lot of people that are using telephone lines, but you still need to provide them in every room. Electrical meters will measure and record the watt hours of electricity used by the building. Each residence is required by federal law to have a meter so that there isn't a waste of energy. It kind of helps you keep track of how much you're using. And these are usually placed ahead of the building's shutoff switch. They cannot be turned off. So if your power goes out, your meter will still have access to the city electricity. The layout of the system will begin with the electrical panel. In residences, these are typically combined with the meters. The main panel of a large building is called a switchboard, and it provides power to a number of other areas. Finally, electrical closets are found in large buildings, and they house the electrical equipment, panel boards, and controls, and those are usually located on each floor and stacked vertically, like in the building core. Okay, the last thing I want to talk about is energy conservation. So one thing that certain municipalities do is something called demand control, where they actually offer higher rates or lower rates depending on peak time. So during the hours where everybody wants to be doing their laundry or everybody wants to be doing their dishes, electricity will be more expensive. And then during the off hours, electricity will be cheaper. So it kind of encourages people to use appliances later at night or earlier in the morning. Another thing that you can do as a designer is specify energy efficient equipment. The average home in the United States leaks about 50 watts of electricity continuously through appliances that are plugged in. Even if you keep your cell phone plugged in and it's fully charged, there's a little bit of power leaking through there. That totals to more than $3 billion in the US per year of wasted electricity. So look for Energy Star equipment and encourage your clients to unplug equipment when it's not in use. All right, that's it for this video. You got one more left.